Find f of a plus h, and the difference quotient f of a plus h minus f of a all over h, where h is not equal to 0. We're given the function f of x equals 6x cubed. This particular process will work for any function. First off, remember that when you have a function f of x, this x is going to be replaced by whatever number it is, or letter in this case, that we want to evaluate the function for. And if we replace that x with a number or a letter, we will also replace that x. So anytime you have a function, for example, let's say we have f of x equals 2x squared plus 3x. If I want to evaluate f of 2, that would be equal to 2 times 2 squared plus 3 times 2. I'm not necessarily concerned about evaluating this particular function, but I do want you to understand that what we're going to do is substitute in the value inside these parentheses wherever you see x in your function. And that's what we're going to do in this case. So the first thing that we want to do is go ahead and find f of a. That means that we will replace a, or I should say replace x with a in our function. So if a is the value that we want to find, we'll go ahead and simply state, okay, 6 times, and then we'll replace x with a, and that's to the third power. That's your answer, 6a to the third power. Now, the next one is going to be a little more tricky simply because we're going to have to expand a binomial. When I say binomial, I'm talking about this a plus h. So it will be f of a plus h, and that means that what I'm going to do is replace the x in my function with a plus h. So this becomes 6 times the quantity a plus h cubed. And then that's a binomial, which I will then multiply by itself 3 times. There are a couple of different ways to approach this. I can actually go ahead and multiply this out. In fact, I'm going to use the FOIL method here. That's going to be f outside, inside, last. So we'll do that. This first binomial remains unchanged. And we're going to multiply a times a and get a squared, plus a times h, we get ah, plus h times a is also ah, plus h times h is h squared. Noticing that I can rewrite this as a squared plus 2ah plus h squared. And now I'm going to multiply that by this binomial. I don't have a neat mnemonic like the FOIL method for multiplying two binomials together when I multiply a binomial by a trinomial. So instead, we're just going to go ahead and use our traditional distributive property, which that is what we're doing with the FOIL method, but it gives you this neat little trick. So we take a and we're going to multiply it by all 3 terms in the trinomial, and that's going to give me a cubed plus 2a squared h plus ah squared. Then I will multiply h times a squared times 2ah and times h squared. And what I'm going to do is I'm going to line up my variables by order. So h times a squared is a squared h. And then I'm going to add to that h times 2ah, which will be 2 which will be 2ah squared. And then h times h squared is h cubed. Then what I'm going to do is go ahead and add by columns. I'm going to add my like terms together, and I end up with a cubed plus 3a squared h plus 3ah squared plus h cubed. Now, what I've just done is the long way. I could use something called the binomial expansion. And what that does is that involves using Pascal's triangle. So let's look at that for just a moment. What you will notice is that in this particular instance, we have a coefficient of 1 here, a coefficient of 3 here, and a coefficient of 3 here, and then another coefficient of 1. You'll also notice that the sum of the exponents in each individual term is 3. This is 3. Remember, this is h to the first, so that will add to 3. This is a to the first, which will add to 3. And then this is 3. Using Pascal's triangle and using what we've just talked about, which Pascal's triangle looks like this. And what you'll notice is that this right here is some binomial a plus b to the 0 power, because anything raised to the 0 power is 1. This is going to be a plus b to the first power, noticing that these are the coefficients. Notice a plus b to the first power is simply going to be a plus b. And that's going to have a coefficient of 1 on the a and a coefficient of 1 on the b. This is going to represent the expansion for a plus b squared, noting that this is the coefficient for the first term, coefficient for the second term, and the coefficient for the third term. And in fact, if I write a plus b squared, I will have 3 terms, and I will have a times b, and then b, and then what's going to happen is this has a coefficient of 1, a coefficient of 2, and a coefficient of 1. Now remember, we also have to have the sum of the exponents of each term equal to 2, so this will be a squared. A to the first times b to the first is a sum of 2, and this is b squared. Which brings us to the next part of the triangle and what is going to allow me to expand that rapidly. Notice that the coefficients in this expansion are 1, 3, 3, 1. Notice that in this triangle, it's 1, 3, 3, 1. One of the things that I also want to point out is in Pascal's triangle, notice that 1 plus 2 is 3, and 2 plus 1 is 3. And so I can easily get the next row. For example, notice that they're all 1s down the outside of both sides. And then this would be 1 plus 3, which is 4. 3 plus 3 is 6. 3 plus 1 is 4. And now, if I want to go to the next row, I would do 1 here. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. And then I would put a 1 down here. So this is just a quick example of what Pascal's triangle does anytime I have a binomial and I want to square it, cube it, raise it to the 4th power. The numbers that you're going to have will change a little bit depending on what your actual terms are. In this case, we're using a plus b, but if I happen to have something like 2x plus 3, I have to take into account the 2 and the 3 when I'm expanding this out. But that's beyond the scope of this problem. So anyways, back to what we have. That means that this function is going to be equal to 6 times what we just came up with, which was a cubed plus 3a squared h plus 3ah squared plus h cubed. Don't forget that you're going to need to go ahead and multiply the 6 through, and we end up with 6a cubed plus 18a squared h plus 18ah squared plus 6h cubed. The next one that we want to find is the difference quotient. The difference quotient is going to take what we just found for f of a plus h, And we're going to subtract f of a from that, and then we're going to divide by h. So let's look at that. And so that's going to be equal to this function right here. And note that I'm going to put it in parentheses just for the moment. And we're going to subtract f of a, which remember, we'll scroll back up so we can look at it, is simply 6a cubed. So let's do that right now. We'll subtract 6a cubed. And now you'll notice that once we divide it by h and we apply our operations, for example, let me go ahead and remove the parentheses now. This 6a cubed minus this 6a cubed, those will add to 0. And you'll notice that I'm left with 3 terms in the numerator. All 3 of them have an h in them, which means that I can divide this h out. And so what I'll do is go ahead and write it into 3 individual fractions, just so that you can see the process of dividing the h's out. And that's going to be equal to the following. This h will divide into itself and into that, and I'll be left with 18a squared. This h divides into itself, but there's 2 of them here, so that's going to leave me with an h, so I have plus 18ah. And in here, h divides into itself once. And up here I have 3 of them, so now I'm left with with h squared, and I have plus 6h squared. And that's your difference quotient.